Hi, hello everyone. This is Pooja. I am excited to be presenting at the Conference 42 Machine Learning of 2026. What a great way to start a year talking about the it of the IT industry and the it of all technology, that is machine learning and all the cool advancements and developments we're seeing in the industry here. So let's dive into it. Let me share my screen and yeah, okay. So I will go into the slideshow mode. Yeah, let's talk a little bit about me first before we get into the fun stuff. I am Puja Ranjan. I am an engineering manager in Oracle America. I work in the Silicon Valley. I work specifically for Oracle Cloud. Oracle Cloud has a lot of, and recently Oracle Cloud was the winner in the second winner in the category of highly fast growing cloud companies according to Gartner ratings. We are doing a lot of cool cutting edge feature development for cloud. And the push in the last couple of years has been totally towards building more AI centric tools that will simplify enterprise use cases and business use cases. So, yeah, I've been in this space for about over a decade now. I started as an software engineer. I worked on several SaaS platforms and projects. I worked on one of Zoom's competitors. Actually, Zoom is our online meeting solution that most of you are aware of. There is another product called GoToMeeting, and I was the person who started as an entry-level engineer and then went to the lead engineer level there on building it, deploying it, hosting it, and shipping it, and constantly collecting customer feedback and then keeping on optimizing that product. Over Oracle, like for the past 4 years, I started as an engineer in this team as a lead engineer, and then I shipped out some AI/ML solutions for the cloud. My target audience has been data scientists. So I build machine learning related tools that they could use in their day-to-day lives to make the entire ML engineering pipeline simple for them and to leverage the security and reliability and availability of the cloud to make their lives easier. Over the past 3 years, I have been leading a team of engineers. It's a mix of software engineers and machine learning engineers, and we try to again come up with the coolest tools that we can ship out to data scientists so they can easily extract. If they have fragmented data sets, they can move all the data set on the cloud. So for migration purposes, for data labeling purposes, for to organize the data, especially unstructured data, to search through their data, all the tools that Oracle Cloud provides and other providers also, other competitive cloud providers do. At the same time, we help them, like models are a very big part of ML engineering, right? Building models, all the tools that they need to have like smart models, smart model building, and all the content packs that they need, all the environments they need to set up. We provide tools for that. After that, we also do some more ML tools to once their models are ready. We provide ML tools. I overlook those divisions where we deploy those models to our large scale, heavy duty bare metal instances where there is very little hypervisor between you and your workload. Or we have them deployed to GPUs that are shipped by standard manufacturers like NVIDIA. So deploying those models, training them, retraining their models, storing the results, doing performing analytics on them. And so these workflows basically are a part of my day-to-day life. So yeah, let's go to why what we're doing right now in the Silicon Valley is important for the machine learning evolution altogether. So machine learning obviously is having, especially now AI, large language models, integrating them, using them is drive that a lot of large scale cloud organizations and also smaller startups, smaller AI startups are totally going for. The trend that I see in the Silicon Valley is, hey, let's solve the more business use cases we solve, the better it is. For example, a simple one is IT support. So in the past, organizations and my current organization, anybody having a problem with setting up a policy or having an access issue while logging in or accessing some specific tools or information had to go through obviously the vetting, and there was rules around who can get access and whatnot, but then troubleshooting was an issue. So then you had to wait for a person to unblock you or come and help you out. Sometimes the person had to be on site to help you. That could add some more delay and some more frustrations to you trying to get your job done, but having these logistical issues. But now, with all these AI ML models and innovation, that bit has been, I would say, 70% automated, because most of these articles on how to troubleshoot and how to go deeper when something is wrong are all written, but they are fragmented in so many places across the organization's databases. And then sometimes some of this information is also just public information. That's some of Google's websites. So we have now in the AI space deployed models that are smart IT support assistants. And the past 3 tickets that I had to file because of some missing access or permissions were resolved by just talking to the bot in my organization. The bot could point me towards the right documents, walk me through the steps. It could exactly pinpoint which permission or which user group was I not a part of. And I also asked it, hey, but I was a part of this. I didn't know I was thrown out. So then it put together a plan on how to, it will automatically set up a reminder for me to renew my permissions every time they expire. Yeah, this is just an example of how we are now integrating models into our space of software development, machine learning engineering, the whole technology bracket, basically. And that is helping us focus on the real problems of data scientists and ML engineers, rather than spending our time on the logistics part of everything that we need to do to have access to our systems. Yeah, and just this example, if you look at the entire flow end-to-end pipeline, be it machine learning engineering pipeline or software development engineering pipeline that's ML enabled, all these pipelines are very heavily inspired now and are benefiting from having machine learning integrated in several aspects and several phases of their projects. Why is all this important? Because if you look at the revenue and the business that SaaS systems, that cloud systems generate for the Silicon Valley, it's over 350,000, 350 billion plus revenue annually. And like just 3 to 4 top players of the Silicon Valley are able to bring this revenue together. And not only does it create this huge industry with huge revenue, it is also providing a lot of governance and regulation in terms of how smaller businesses or enterprise customers, or even a small or a personal entrepreneur, if I want to have a small shop on eBay or Etsy to sell a few of my things, I would be able to do that in a secure and a reliable way by creating an account with one of them. So it's empowering people to go and build and focus on their actual business use case. Just worry about how will I sell this and not worry about, oh, how will I host this? Will my website be up all the time? Will I be under some sort of security threat? Will my customers' data be lost? So all these problems can be outsourced to the cloud, to a SaaS organization. And you as an individual or as a business owner can only focus on your business use cases. How do I get my customers to buy my things? How do I boost that? Or what are the problems? Why are these products not selling? Or why is this the most highly returned thing in my catalog? So you can focus on that, and you can use ML engineering for that as well. But the whole logistics and deployment part of it that helps you maintain an online presence, all of that has been shipped out, and that empowers you to have more smaller businesses, and in turn then generating more opportunities, more revenue, and so on. So now that if you think of like a customer or a person who wants to use, I can actually give a data scientist example because that sounds more machine learning. So if we talk about a data scientist who wants to maybe has fragmented data sets and now wants to put everything together and extract meaningful patterns from it, see and get the most out of the data that they have, what can they do about it? As step one, right? If they come to a cloud, or if they go to any cloud organization and request for certain services, like how do you start? The first thing is like feature definition. So you might have a lot of data, but what are you expecting to get out of the data? There are two things. What are you expecting versus what the data is already giving you? So for you to, okay, I expect this data to tell me the number of consumers or the months in which the sale of certain products go up. And now I have this retail data that's billions and billions of terabytes. In these stages, what you do is that you use AI defined models. Like organizations will offer you a support, an option to choose, okay, do you want us to tell you the latest and the greatest of what the industry wants. You may or may not have that data, but there exist large language models now that organizations will offer you for a nominal fee. And these models train on the latest marketing trends that are collected. And there are several sources. We're not going to go into the sources of how marketing data is collected in this, so the purposes to keep the scope limited. But assuming that there exists marketing data from several sources, there do exist a whole bunch of models that will help you train, that will help you pull out advertisement specific information to help you what is the next big feature that your customer wants. So, as a data scientist who wants to get most out of data that is sales related, our AI ML models integrated to our system will give you an insight. They will train on billions and billions of sales data sets, excuse me, and they will tell you what is the next cool thing the customer wants. A recent example in our times has been some customers requested auto code, like a code assistance integration into their development environments where the code assist could explain code to them, it could interpret the code for them, it could auto generate some unit tests. So, all these things, that's a feature request that even the customer did not know that they wanted. But when AI recommended these things to them, they were very happy because, oh, wow, I could do something like that. After that comes in the part where maybe the data scientist is not very heavily involved, but it could move towards the software development engineering part of it, where machine learning engineers actually come into play. They look at architectural design and UML compliance. If you have a feature request, how will your provider provide it to you? They could either have that feature available and it's just about doing the legalities and the sales part of it where you come on board. But the other bit is if the feature is missing, we will go back, the cloud provider will go back and build it for the data scientist. At this stage is so every cloud provider again follows very strict networking patterns. Architecture 2A, 2B, 2C, 3C are some common examples that can be Googled in networking patterns. And then there are compliance tools that make sure that every time you make a feature request, sometimes it's called release management related tools. What these tools do is every time you generate a new design for a new feature, they run some compliance checks, they run security checks to ensure that you're not creating a breach or a leak. They run some regression, they set some platform acceptance standards in related to in with regards to testing. And they also make sure that the new architecture that you're introducing, the changes, are you introducing API changes? Are you introducing UI changes? Are you introducing like an infrastructure as a level kind of change, which is like a Terraform change? If you're doing all these, then there are other regulatory standards to ensure that your changes do not break or regress anything that the organization is already offering. Once the architecture has been laid out, that's when secure development and testing comes in. There's a huge bunch of software engineers who will build code, who will build. They might use code assistant technologies again to interpret, comprehend, to refactor their code, to test the performance of their code. Once that is done, once they open a pull request, as we call it, a pull request, there will be several tests run on it. Although it does require some level of manual approval, it's not touchless totally. We do want developers to look at other developers' code and ensure that, hey, this change looks good to me as a developer before we let AI and ML take over and run compliance checks on it. Once that happens, it's usually merging and then putting it out there. The deployment pipeline is totally orchestrated to be touchless. So once you build and test in a certain testing environment, you will roll it out to like you will have a Terraform level infrastructure as a service tool that will help you roll out your changes into a more production like environment first and then into an environment in the live environment where and usually you deploy it into a smaller scale region where there are lesser customers. Again, you have that insight from the data that you collect and then you deploy it to all your popular regions with minimal impact to existing performance of your system. And then along with this, there will be some compliance verification standards that run. So there's SOX as VPAT, data governance. So there are every country basically has some regulatory standards around data. It implies not only to accessibility and security, these compliances also apply to ease of use in simple terms. So, for example, VPAT compliance says that your websites have to be accessible to anybody who is using a screen reader or like an interpreter device, because they could have some hearing or listening or speech related disabilities. So your website should be very accessible to people like these. SOX compliance ensures that everything that you promise a customer or a data scientist, you have set minimum acceptance standards. And unless those standards are met, you cannot call that criteria done. Of course, there are more legal and sales related terms that come, but these are at the core software engineering level. These policies are established for a software engineer to manage the expectations and the requirements of a product. So once a data scientist has requested a feature that maybe was not there, but they wanted to use it on the cloud, and the software engineering teams and ML teams have built it and deployed it, there will be some level of continuous monitoring and automation, and that also requires a lot of tools and ML specific tools. We'll talk about them a little more. So yeah, what have introducing these tools and letting smaller businesses, data scientists, what has this done to the industry? What it has primarily done is that it has empowered them, as I mentioned in the past. But how do you continuously monitor something like that? So to continuously monitor something like that, companies typically sign an SLA, service level agreements. And these service level agreements, again, they come at the legal aspect and sales aspect first, where there'll be terms, you will sign clauses with the companies. But for continuous monitoring, a company usually promises like 99.99% times availability, that the service is going to be up. If you host your website on our cloud, excuse me, your website will be up and running for all of the year except for maybe 2 or 3 hours of downtime, which is unpredictable. Could happen, could not happen, but that's the max your website will go down. And our reliable, secure hardware data centers and all the software we write over it is going to ensure that your website is always up and running. So these benchmarks also, there are other benchmarks around sustainability and clean. A few of them apply to companies internally who are the cloud providers, and some apply to the people, the customer who's walking in as well. And to maintain these compliance and standards and reliability, excuse me, a lot of requests. Okay, now when you send a request, okay, now I'm a data scientist, I'm sending in a new request. I am sending a request to maybe create or launch a notebook or Jupyter Lab notebook, which is actually just a VS Code editor equivalent for a software engineer. Now you launch a notebook because you want to build a model inside it. So the request that I send, it should be fulfilled under 500 milliseconds. If that's not happening, then that's something that I put as a service level agreement to my cloud provider. And the cloud provider then runs tools, automation tools, to ensure that there are constant monitoring alarms, there are health check alarms that run to ensure that this requirement is being met. And the minute we don't even, in the ML world now, we're not even waiting for a breach. We don't wait for the threshold to cross 500 milliseconds before you alarm and let teams know that something is not right. You start alarming at 300 milliseconds. You expect your system to respond within 200 to 250 milliseconds. And then if it's crossing 300, you start alarming, you start creating tickets, and ML engineering not only creates the alarm, but also starts analyzing some possible ways. Like, is there a hardware issue? Is there a scheduling issue? Is there a round robin? Did one of these data centers come down? What happened? Or is there too much overload, and is this a noisy neighbor's problem? Tendency level issues. So everything ML can help you. ML is helping us at this point of time optimize how do we look at these problems and eventually provide like great quality service to any customer who is using the cloud. Yeah, I did touch upon these regulatory frameworks a little bit in the past, so skip these for now. Yeah, now in this pipeline of continuously providing help and doing these things, I spoke about Terraform, Bamboo, and CI/CD. So now we're specifically talking about the CI/CD stack and how it, once a developer or a machine learning engineer has built a cool feature for his customer base, how is that going to land up in these production realms? And what role does AI play here? So although there are these automation tools like GitLab, CI/CD, and even these tools, these are third-party tools, and even these tools are now integrating ML insights through large language models to understand what other compliance gates are necessary. So there are different tools like Clover that will analyze the code coverage percentage. You want to ensure that the best quality code rolls out to your production regions. So for that, you will have an integrated use of these tools and the AI and the algorithm, the large language or the small language model that's optimizing your PRs, your code that's coming in. That will run all these compliance tools. It will ensure that your code coverage is optimal. If it drops below a certain percentage, you're not allowed to merge that code. You have to generate your unit test, you have to generate regression tests. It will run security tests to make sure that it'll do all those standards set of static security runtime where it bombards your like cross to like it will simulate basically cross-site scripting in a way. It will simulate denial of service attacks. So these tools now can auto do these on all your PRs and all your code that you're merging in. And then it will merge it into the master system. It will produce a build. It will produce a build which is like an artifact. And that artifact has to be deployed through Terraform into all these several data centers. And yeah, at every stage, ML is going to keep doing compliance, automation, regression tests to ensure that your delivery is perfect. Yeah, and obviously, the coming back to the resource optimization part of it, yes, hardware optimization is a very major deal for cloud providing companies because sustainability matters. Your carbon footprint matters. We know that data scientists and data engineers who manage like these huge data centers, they know that like the usage of electricity and water to cool these data centers down and all of this has a very huge environmental impact. So you can pay for it and you can afford to pay for it, but then we also have responsibility towards the planet. How are we utilizing ML in this space? Machine learning optimizations. Now most organizations, right, engineering orgs, especially huge orgs, that all orgs that manufacture hardware or use hardware at a large scale, they do have several machine learning tools, like something, it could be called something like a cloud guard, where these tools constantly keep monitoring the usage of every server instance that is brought up. And if over a period of time, if it senses that, hey, your utilization is always lower, then it will automatically resize your instances to a smaller size. It will run all load and performance tests to ensure that the quality of service is not degraded, but you end up having some savings on how much CPU or GPU bandwidth or memory that you're using there. You will start saving on that, and that will have a good environmental impact. Yeah, so I spoke about these policies in detail and how are we building and monitoring at every stage of deployments. And yeah, in summary, I would like to say that this is just the beginning for most ML and AI integration systems, and it's a promising future ahead. We have a lot of business and data science based use cases that are benefiting and will continue to benefit in the future because of the integration of large language models and prompts and the data that we have collected over decades and decades. And the growth of and the explosion of AI for not only like smaller level use cases, but even very high level use cases, like or completely replacing search algorithms with large language models. These things are in progress and these things will continue to grow with time. And it's a very exciting future ahead. So thank you for joining me on this talk, and I hope to see you guys in person in the in person meet. Thank you, everyone.